welcome. So today we're going to talk about the Pythagorean Theorem. I know you've already covered it in class, but a lot of us could benefit from a review of what it is and the components of it and how to use it really. So Pythagorean Theorem, what is a theorem? In algebra, a theorem is a rule, usually presented as a formula. So we all know the formula by now. We're going to get to that in the next piece, but let's look at this triangle. So remember, the Pythagorean theorem, it's a story about a specific kind of triangle, about a right triangle. So when we talk about Pythagorean theorem, we're talking about right triangles. And we can use it to prove whether or not a triangle is a right triangle or not. We can use it to find any leg or the hypotenuse we want. But there's a few things we have to know first. So we have to be sure that we're dealing with a right triangle. We know it because it's often represented with our right triangle symbol. We also have to be able to identify our legs, A and B, both legs. And in your formula, please do keep A and B as your legs. They must be your legs. And finally, C, which is your hypotenuse. And that is the longest side that is opposite the right angle. You can always find your hypotenuse by identifying your right angle and seeing what is opposite to that right angle. That will always be your C. So let's start with this practice problem. Now remember, you always want to be thinking, what have they given us? What is the rule? And what am I expected to find? What have they given us here? They've given us, what kind of a triangle is this? It's a right triangle because it has that right triangle symbol. We know it. They've given us the length of one side as 4 inches. They've given us, the length of another side as 5 inches. And this side is unknown. They've also given us the formula for the Pythagorean theorem. A squared plus B squared equals C squared. That is, when I square leg 1 and I add it to the square of leg 2, it's going to give me that hypotenuse squared. So now let's determine what they've given us so we can use our formula. They've given us, well, we know this is the right angle, and this points to the hypotenuse. The hypotenuse, or the longest side, is always opposite that right angle. So we know now in our formula, we can fill in our hypotenuse. We know this is going to be C. So we'll put that here as 5, and of course we're going to square it. We're going to square 5. Now, coming back, I have one side, 2 sides, which are my 2. You got it, the 2 legs. So one leg is 4, and I'm going to call that A. And my other leg is unknown. I'm going to call that B. So I can put 4 in for A here. 4. And of course I'm going to square it. Plus B squared. Do I know the value of B? I don't. I'm solving for B. I'm going to leave it as a variable. Equals 5 squared. So let's take it a step further. Let's solve what I know. I know 4 squared is going to give me 16. I'm adding to that B squared. I don't know the value of B, so I don't know the value of B squared. I'm going to leave it as is. Equals 5 squared gives me, you got it, 25. So now I have this linear equation that we've been practicing linear equations all year, and I know we have a certain comfort level with solving this. The one thing that we might struggle with, these squared and square roots. So let's take a look at it. 16 plus B squared equals 25. So remember, B is my variable, and I want to isolate that. I want to get that by itself. So what would I do with 16? Some might say we bring it over the bridge of change, which would be that equal sign. Some would say that we just subtract 16 from both sides because it's a positive 16. I'm going to go with that bridge of change model because that's what we've been working with all year. So I'm going to take that positive 16 and I'm going to take it across that bridge, that equal sign, and I'm going to put it over here, and that becomes minus 16. Taking it down the next step, I now have b squared equals 25 minus 16, which is going to give me 9. B squared equals 9. So I'm almost there. This is a one-step equation. So this is where a lot of us might get stuck. So I know that b squared gives me 9. I'm going to square some number to get 9. So remember inverse operations. I want to undo this squaring. How do you undo the squaring of a number? You take its square root. I want to find the square root of 9. And for demonstration purposes, I'm going to use a calculator. It's always okay to use a calculator with this because square roots and finding square roots can be difficult. So I'm going to use a calculator. We may already know the square root of 9. Make a prediction. What do you think the square root of 9 is? And let's check that prediction. So the way we do it on this calculator, we enter in 9, and we simply press the square root key. If you see it, it's right above my finger, the square root key. And it's going to give us the square root of 9. And I get 3. If you guessed 3 or you knew it was 3, nice work. So when we found the square root of b squared, we got b. We undid that squaring. And when we found the square root of 9, we got 3. That tells us 3 is the length of this leg right here. So it's going to be 3 inches. Okay, here's example number 2. Remember, we always want to be thinking, what am I given? What is the rule? And what do I need to find? Looking at the diagram, what am I given? I'm given a triangle. It is a right triangle. And I'm given the lengths of 2 sides, 7 meters and 12 meters. Now, since it's a right triangle, you should automatically be thinking, okay, I can use Pythagorean Theorem if there's something that's missing. If one of those side lengths is unknown, I can use that Pythagorean Theorem. And again, Pythagorean Theorem is right here. So we're given this right triangle with 2 sides and 1 missing side. What is the rule? Well, the rule is right here. It's this Pythagorean Theorem that says 1 leg squared plus the length of the other leg squared is going to equal the hypotenuse squared. So let's go back to the diagram and figure out what exactly do we have. Do we have A and B, or do we have A and C? Let's take a look. So first thing you want to do is, where's your right angle? Right here. Well, we know the side opposite the right angle is going to be my hypotenuse. Well, opposite the right angle is going to be my hypotenuse, and we represent the hypotenuse with letter C. So I know I'm missing C, and I know that I have A and B. So I can start putting this into the formula and come up with an answer pretty quickly here. So let's do that. I'm going to call this A. I'm going to call this B. So let's substitute those numbers in. A is 12. A is 12. 12 squared plus B. B is 7. 7 squared equals C squared. Do I know the value of C? I don't. So that is my variable. Let's take it a step further. 12 squared is 144. Awesome job if you already knew that. Plus 7 squared gives us 49 equals c squared. I still don't know the value of c. Okay, let's combine some like terms here. 144 plus 49. I know a lot of us can do this in our head, but I'll do it down here for good measure. So 144 plus 49. 9 plus 4 is 13. Carry my 1. 4 plus 4 is 8. Plus 1 is 9. And then 1 plus 0 is 1. So my sum is 193. So when I added these two together, I got 193 equals c squared. So now this is back to a one-step equation. And again, a lot of us might struggle with dealing with these square roots. So c squared, some number squared, is going to give me 193. How do I undo the squaring of a number? Think for a second. How do you undo? What is the opposite of squaring a number? If you said finding its square root, you were 100% right. I want to find the square root of this, and I want to find the square root of 193. So I already know the square root of c squared is going to be c. I'm undoing that squared with the inverse operation, which is finding its square root. So c equals, well, what is the square root of 193? I'm going to get my calculator out for this again because this is not mental math. So to find the square root of 193, all I do is enter 193 into the calculator and I press that square root key, which is right above my finger. It's the X with that square root symbol. The square root of 193 is 13.89. I'm only going to take it out to the hundredths place. 13.89. C equals 13.89. Let's put that back into the diagram. So C equals 13.89 meters. So in both of these examples, example 1 and example 2, we did the following. We observed the diagrams and what was given. We determined what is the rule based on what we analyzed. And then we figured out what is it we need to find. So we used this Pythagorean theorem, and really we used our knowledge of solving linear equations to find the answer. So we're relying on that previous skill of solving 1, 2, and multi-step operations in the context of geometry. So I hope this lesson was helpful. I know that you had lesson 16 in your support coach books to do, and that was all about Pythagorean theorem. This is a good recap of those skills that you need, some of that vocab and some of those processes to actually apply the Pythagorean theorem and analyze right triangles. So hopefully this again was helpful, and if you need to go back to that lesson or other work from Ms. Diaz, please do so, because this might be a good reference for you to master that.